In this video, we're going to talk about slope fields, which is a concept that comes up from working with differential equations. So first, before we talk about slopes, we need to talk about fields. And a field is a concept in math or in physics or a number of places where each point in space or in a kind of region is assigned a value. So below you see an example of a kind of a field. It's a close model, but we can see how every single point on this map, more or less, has a number, and this represents temperature. Now, this isn't a true proper field. It's kind of implying or approximating a field. A true proper field would have literally every point have a number. So we wouldn't be able to see it because, all the numbers would overlap, but, down to the infinite detail, every point would have a number. So like, for example, we've got a lot of empty space in the Black Sea here, but we'd expect to see numbers. And we can kind of guess what those might be. So this might be 11.1, this might be 11.9, and there might be an 11.5 in between. So this kind of implies what the in-between values are. And this could be considered a representation of a field where we've just picked a handful of numbers and then we've ignored or kind of left off the other numbers that do exist. But that's the example of a field, is something where there's a value assigned to literally every point, not just, discrete, if it's a grid, not just the points on the grid, but every single point in between. So now how does that connect to differential equations? A slope field, sometimes also called a direction field, represents a differential equation by representing the slopes of every point in space. Because if you remember, a differential equation of the form dy by dx equals something, that's telling you dy by dx can tell you the slope of a point. And we do this by drawing a bunch of arrows that are tangent to that slope. So what does that look like? That looks like this. So this is a highly detailed, or a fairly highly detailed slope field. And it's for the equation y prime equals 3x plus 2y equal minus 4. So this is a differential equation. And what we've basically done is we know dy by dx is the slope. So this is the slope. And then at every point in space, they just plugged in the x and y values, found that slope, and then drew a line that is roughly the shape of that slope. So we can see it, for example, at, I know the yellow's hard here, but at 2, 1, if you plug in 2, you get 6. If you plug in 1, I think this is the wrong value. I think this should be minus 2y. We'll double check that in a second here. But if we plug in 2 here and 1 here, we get 6 minus 2 minus 4, which is 0, and we see 0 slope there. Let's find another one. I think that this should be a minus 2y, because then, if I plug in a point, say 0, 0, I get negative 4, and we get a really negative slope here. If I plug in 1, 2, I get 3 minus 2 minus 4 is negative 3, which we also see a negative slope there. So you can see how plugging all this in and then just drawing these little tiny arrows, we get that rough idea of the slope field. So slope fields are created by calculating the slope at every point in space and drawing a small arrow. Typically, these days, you're going to only do that with a computer. If it comes up on the AP test, I've only ever seen it with 6 or 8 points. So there might be something like this, where they give you, say, these 3 points, or, maybe as much as 9. And they say draw a slope field using these 9 points. And so, you draw like an arrow like this, maybe an arrow like this, that. So, you might have something along these lines. So you just draw a handful of arrows, you only have to calculate a handful of slopes. How do we use the slope fields? Well, on a slope field, the solution, or a solution, is any curve that matches or conforms, we would say, to that slope field. And the way you do this is you just basically try to follow the arrows. So you start at one point and you kind of draw a line and just have it curve along with the arrows. So here's an example of a slope field. T prime of t is equal to negative 0.4 times, I don't know why this is in the notes, but this should be y and x. Let me just restart that. Y prime x is equal to negative 0.4 x minus 72. We've got two solutions here, and you can see how these red lines sort of match along with the arrows. They sort of trace along with them. If I wanted to produce another solution, I can easily do that just by picking another point, say here, and just kind of sketching, and I see that my arrows are generally going in this direction, and just sort of following like so. So how do I know, how do I get a solution, a specific solution? Well, if they told you the solution passes through this point right here, I don't know exactly where we're looking at the graph, there's no numbers, but if it passes through here, well, I can go backwards and sort of follow those arrows, and I can go forward and sort of follow those arrows, and then this curve that I've drawn is the solution to that specific solution to the differential equation. You'll never have to like describe these mathematically. It just, they might say like, what is a possible solution? Or you should be able to kind of visualize a bunch of these to get a sense of what the solutions might roughly be like. Are they cubic functions? Are they squared functions? That sort of thing. So that covers slope fields. It's a very hand-wavy as far as how we treat it in AP Calculus, just broad general idea. But it's really useful for visualizing differential equations.